Do you work with serverless and find that sometimes your serverless YAML file gets really big and becomes hard to work with? In this video, we're going to be looking at 2 ways that you can solve that problem. Hi guys, my name is Sam with Complete Coding, where our aim is to make you into the best serverless and AWS developer that you can be. In this video, we'll be looking at 2 ways that you can refactor your serverless YAML file to make it smaller and easier to work with. The first method is to declare parts of your YAML in a separate file and just require that file in. And the second way, and the way that I prefer to do things, is to use a serverless.ts, so TypeScript, instead of using YAML. This comes with some really great advantages, so make sure you stick around until we talk through those benefits. So let's jump into the code, have a look at a serverless project set up with YAML, and how we can make things easier to work with. So to start out with, we're going to be looking at a normal YAML file for serverless and discussing what some of the limitations are. So here we have a pretty bog standard YAML file. It has our service, framework and provider. And then we have our functions. At the moment, we've only got 3 functions. 2 HTTP functions, and 1 that is triggered by S3. This is pretty normal, and with a project as it grows, you could expect to have 20, 30, even more functions in here. So this section can grow quite large. As well as the functions, you've then got the custom resources. So this is a section which often gets quite large, as you have to define a lot of things often in here, and they are in a very similar format to CloudFormation, which is quite verbose in its way it works, so the code here becomes quite long. In our example, we've got a configuration dynamo table. We also have then a Cognito user pool, as we want to add Cognito as the authorizer for our API. We then have the Cognito user pool client, web user pool client, user pool domain, identity pool, and then we're also going to have some roles associated with those identity pools. So there we have the authenticated role. So this in itself was about 65 lines, which isn't too bad, but that just adds on to the length of the file. And then you move on to how you host a front end or an asset bucket or something like that. So here we have an S3 bucket, and then we also have the access policy, as well as a CloudFront distribution, which allows this S3 bucket to be more easily accessed from a local distribution. So if we go all the way to the bottom of here, we can see that this file is 255 lines long. That's not too large to work with, but as this project grows over time, I've seen serverless YAML files reach 1,000, 2,000, almost 3,000 lines before it became absolutely unmanageable. Luckily, there is a way to fix that. So what I've done is I've refactored this slightly. So if I git checkout split, I've created a new branch, and in this one I've used something called declaring variables from external files. So here our functions, instead of being coded inside our serverless YAML, we've created a file under serverless and functions, and we basically say insert the content of that file in this location, and the content of that file is exactly what I've done before. I literally copied and pasted this into this functions YAML, and I've done something similar with the resources. So here our resources file contains all of the resources we just talked through. So there's 220 lines of resources, and that is a lot cleaner. In our base serverless YAML, we literally have 12 lines of code, which makes this cleaner. The issue we've got with this is if we go into our resources, that is still 200 lines long, which makes it less manageable. It'd be really nice to be able to break this YAML file into even more small chunks. The issue is that with this file reference, you can't join multiple objects into a single object as you have to with resources. Luckily, there is a way around that. So if I go and check my second refactor, so git checkout split 2, the core serverless YAML file looks exactly the same, apart from the resources this time reference a JS file. So this is a JavaScript file that I've created, and the difference with a JavaScript file is you need to declare a function and then just return any values that you want. In this case, I'm returning the resources object, but because we're now in JavaScript world, we can do things like spreading the Dynamo object into the resources object. So what I've done is I've split out the Dynamo section of our resources, the Cognito section, and the S3 and CloudFront section into their own files. Now the longest one of these is 90 lines long and is more isolated and contained, so that this is describing just one part of our application. And for example, Dynamo tables, we know exactly where they are, and if we need to add a new Dynamo table, this is where we go. So this is probably the best you're going to get whilst still using a YAML-based configuration. It's a bit confusing because if you want to read these Dynamo YAML files, we have to use fs and a package called YAML for loading in the YAML and turning that into JSON, which isn't the nicest solution, but it works. The only real limitation with this is if I go into something like functions YAML, and I want to add a common authorizer to all of my HTTP endpoints. Well, there are two ways of doing that. Either I can write the authorizer by hand in every single one of these API endpoints, which will work, but if I need to update it, then I will need to update it in every single place. If you end up with 30 or 40 endpoints, that's a lot of repetitive work. The second way is again using that file reference. I could create a new file called authorizer common, and then in here I could define the authorizer and say that that is going to be the file and point that at the correct file for the authorizer common. Doing that in each place would mean I only have one place that I want to change my authorizer, and it will be applied to all of my endpoints. That's quite nice, but if, for example, cause, we want to set cause true on each of our HTTP endpoints, we would have to do the same thing, but then you're literally creating a file called cause settings, which is going to be a value of true. That seems a little bit of an excessive effort just to have multiple things referencing the same variable. The way that I would suggest for everybody that uses the serverless framework to do their applications is to do it using either JSON or TypeScript. So here I've got exactly the same repo with some extra little bits, but the main part is the fact that this is using serverless.ts. Now the way this works is that it exports an object that is identical to the serverless YAML. This is the serverless configuration I've defined here, and I'll show you a couple of the benefits. The first benefit is because it is just TypeScript or JavaScript underneath, then we can do things like the spreading natively inside the single file, instead of having to switch between YAML and JavaScript. So here I'm just importing some objects, so the Dynamo resources, the S3 bucket in CloudFront, as well as the Cognito resources, and I'm just spreading them into the resources. Another advantage is that here we have our functions, and that is just a variable that I've declared, imported from our functions file inside our serverless folder. So if we have a look at those, this here, we are declaring our functions, and that is everything we need. In here, I've actually done some of the things we talked about in the last section. So here we have CORS settings, and I've just declared a CORS settings object at the top of this file, where here we've actually got some more details. So we've got some headers and allow credentials as false, and I can then reference that in any or as many of my API endpoints as I would like. I do the same thing with the authorizer. So here we're saying the authorizer is going to be a user pool, where we're basing that off the Cognito user pool that we're creating in the Cognito resources section. This can be then pulled into as many of the HTTP endpoints as we like. You can do this all in just JavaScript, but another reason I quite like to do it in TypeScript is everything is strongly typed. So here we've said that this functions object is going to be of the type AWS functions, which comes from our serverless.ts. This is the AWS config, and we're saying that we're looking at the functions. So if I jump back into that file, this is going to have the type of aws.functions. This means that in here, under get flights, if I want to add another method onto here, so let's say I want to add an operation ID, I can just press the letter O, and it knows the properties that are available on a HTTP method. Even mousing over, you can see all of the different methods, and you can see the authorizer has ARN, authorizer ID, and claims. And so if I just type O, I can see that operation ID is there. I can also do things like if I type a number in there, it's going to complain saying that number is not assignable to operation ID because that is meant to be a string. These little things aren't massive, and if you look at the documentation, you can find this all out yourselves. But just having your VS Code or your IDE telling you without having to go into a different browser is honestly really, really nice. Another really nice and quite smart thing you can do is that with DynamoDB, because at the moment I'm using a paper request, we don't need to do anything else. But as this project scales, if we find out that it's going to be more cost effective to go with a provisioned version of Dynamo, then we also want to add auto-scaling to our DynamoDB tables. What we can do is we could create a new file inside here called DynamoDB autoscaling. What that can do is that can read this Dynamo resources, go through and check for each table if the billing mode is provisioned, and if it is, it can actually create an appropriate auto-scaling group for the attributes, as well as any global secondary indexes. This can all be done dynamically, so anytime a new table is added, if it is a provisioned table, the auto-scaling will be added. And all we need to do is go down to our serverless.ts, find our resources, and add ... Dynamo auto scaling, if I can type that correctly, and then import that from our new file. This is one of the real powers of using TypeScript or JavaScript, is that everything is just a variable. It can be imported, you can do some logic on it, and then a new set of data can be exported, which allows for things like dynamically creating auto-scaling groups based on the Dynamo tables that exist. Really simple, and one of the really powerful things that you can do with the serverless framework. In this video, we've looked through how we can make serverless.ymls easier to work with by either referencing subsections of our config from a separate file, and we can even throw in some JavaScript to do more complicated logic, or my preferred solution, which is do everything using a serverless.TypeScript file. This gives you the full flexibility of using JavaScript, so you can use the spread syntax, as well as giving you type security, so you know what types your config should be. If you've learned something new in this video, or if you're thinking of trying out one of these methods, then make sure to give this video a like, as it really helps share this video with more developers just like yourselves. And if you haven't done already, make sure to subscribe, as I'm going to be putting out more videos on serverless to help you become the best developer that you can be. So thank you, and I'll see you in that next video.